Welcome. This is June 18th, 2026. Kubernetes Karpenter Working Group. And um we'll get started. Does anyone have any project updates?
I guess the only one for me is I think balance consolidation is pretty close to over the line. Just needs probably one or two more rounds of review, hopefully one. So pretty cool.
I think capacity buffers is pretty much there as well. If folks are interested in support for capacity buffers, the PR is pretty close.
Awesome.
Can you link that? I want to take a look. I think I saw it before, but I forgot about it.
Yeah, let me grab that. I should link it in the project updates. That's what
Thanks.
it's there for.
Well, that's all we have for project updates. Then we can move on to RCs. So Carvin, you have price expression adjustment.
Yep. I've two, but yeah, price expression. I want another, I guess, review or someone to take a look again at it. I think at a high level, the idea of the RFC is currently overlay for price adjustment. Specifically, you can only apply one, so the highest weight wins. But we have more complicated pricing adjustments, such as like enterprise discount and say licensing fee. So it's very difficult to express that in the current overlay. So I guess for us, we also have like pricing discount plus a EBS volume pricing that we want to add to it. That's different. So we wanted some way to express that in a single overlay. The idea of the RC is simply using cell expressions to show your pricing. Oh, actually, I need to update that. That price times zero point 0.9 is wrong. But ignoring that, um, so yeah, the RC simply goes through like, okay, how can we do this? The alternatives, which is like I think we discussed previously, where we can stack overlays, but then that would change the resolution, the default resolution where highest weight wins to some way of resolving, doing certain actions first. Let's say highest weight goes first, so you do the discount and then lower weight, like add additional things, which could be confusing, but it um, have some flexibility of allowing you to do varying discounts. Like you have a base discount and then you want to add things in higher weights, but then it just also changes the paradigm of how overlay kind of works from the default. So I just wanted people to take another look at this and see what they think about the sales expression and there. Yeah. So just want to bring this up for another view of this RFC.
Thanks for bringing it up. I've been thinking about this more, and how do you feel about just like deprecating price adjustment and making price expression the only thing? The uh,
That
the the API
uh,
is alpha.
yeah, I didn't want to kill off completely right off the bat. Like in theory, the price expression does work for adjust and or even like the current price adjustment raw price, it can do both because price expression, you can just put a number and then you become price. So you can do all of it. And I am, uh, yeah, I'm happy to completely replace them. I just wasn't sure we want to do this right off the bat. I was like thinking we can do this in beta where you have both, and then when we go to GA, we'll kill off the old price and price whatever. I guess we don't have a good idea of path to GA, but I just didn't want to kill it off straight off the bat. And I want some time for user to be like, oh, this is going away, and then goes away, if that makes sense. But I'm happy to kill it off. I don't know how we want to do it.
Yeah, I mean, given that it's an AP alpha API, we can just change it if we want. And I
Sure.
think like the more I'm thinking about this, price expression, if we need the flexibility of price expression, price adjustment and price expression existing, like now do we have to worry about the semantics of if you set both or do like cell validation to
Ah,
say you only set one or the other? Like,
that's why I said in the dogs, like, yeah, if you have price expression, all the other ones get ignored. I don't know, sorry, it veils validation, and you can't have price and price expression. You can't have price and whatever. You can't have any of the combinations. You can only have one. Um, but yeah, it definitely like to me it's like it's fine to kill it. All the other ones.
yeah,
I just don't
I think
know
I
what.
agree.
Yeah, yeah. I just don't know what the way to kill it looks like. But I agree, killing it makes sense to me.
Yeah. I think it's alpha. Price expression, I think is just better. I think we got it wrong when we did node overlay the first time. It probably should have been celled from the get-go. I say
Okay.
let's kill it.
Okay. I'll add
Or at
that
least
point.
that's what
I'll
the
add the
RFC
point.
should
Okay.
say we're doing, and then
Yeah,
people can
yeah.
disagree.
Yeah, I'll add the point to like, oh, our plan is to kill it. But yeah, I can do that.
Cool, thank you.
Yep. Go feel free to go because since I have two RFC, I don't want to take all the time so Derek, feel free to go through yours.
And then we can move on to time slicing.
Sure, yeah, okay. Yeah, okay, so this one I added some more information. I need to shape it up a little bit, but Jason looked at it and pointed out something I was wrong about where I thought every 10 seconds the disruption controller runs, in which case if it's dominated by drift, then it'll be one node per 10 second for drift. But that's not right. The 10 second only happens if it found no disruption and then it spins for 10 seconds and wait for 10 seconds and tries again. However, I was looking at I guess this is where the graph comes in. I don't know if Jason is here today, but if not, I can ping him too. But what I was still seeing is that during just regular like the runtime of Karpenter, we have a high but not that high level of budget for drift, which is like 20 to 30%. I think in this case, in this graph, it's 30%. We are still seeing windows of hours where it's spent on drift and emptiness and not consolidation. The consolidation is blue, yellow is like multi, green is empty, and orange is drift. I should have labeled this on here, but I'll add to the doc. But essentially, we're still seeing windows where drift simply dominates because that budget is just high enough and drift happens just quick enough that no other disruption method below its priority can run. And the idea of this RFC was simply introducing some sort of fairness and scheduling to the disruptions, where you have an explicit order, sorry, where you go empty, drift, and then consolidation. It's possible that the lower priority ones doesn't get time simply because emptiness or drift within their budgets can simply keep running because there's enough nodes for it to happen where you never get to the lower orders. The idea here was taking the concept similar to CFS, like completely fair schedule from Linux, where every time you run, you incur some runtime, and that penalizes you the next time the cycle runs, such that it must yield time after certain use like you run drift for some time, you must yield to the other methods of disruption so that we have somewhat fairness in how disruption runs, such that within over a time interval, every method gets to do its run. and not like right now where you can have hours where the higher tier runs forever or runs for a long time. And in a way, it's a high level. That's what this is doing. So it's giving time to each method such that they get to run. It also opens the door of right now, single and multi-node consolidation have a timeout. Single node has like 3 minute, multi-node has 1 minute, but those are hard coded and doesn't let you see. There's no metric. There's a log, debug log that I timed out. And in my mind, like the reason the timeout exists is because if you set 10 minutes, then the ordering and everything kind of goes in like it's messy because you don't understand anymore if there's an ordering because if single node consolidation runs for 10 minutes, then drift and emptiness doesn't get to run and you might have lost that ordering. But then with this, because of fairness, yeah, it may have gone to run for 10 minutes, but it must yield time because they incurred that runtime to the other methods. So like that ordering comes back, it just at a time scale that's maybe not 10 minutes anymore, right? Like a slightly longer time, but it gives the user some understanding of I can change the timeout, but it will self-rectify within the system because we have some way to penalize you if you run for a long time. Or you run some time and you time out, like you get penalized for that, so that we can possibly expose the timeout because now there is a system in place that like these timeouts kind of don't have weird side effects. It's more like, okay, you know you're gonna take that time, but afterward it must yield time to other methods. So the high level of what this is, and simply to solve a problem where higher priority disruption can dominate the time. Yeah.
Having taken a look at this before, I do like the concept of some kind of fairness between drift and consolidation. I don't know if I love the idea of fairness between the methods of consolidation, given that we have some like, so right now we each of the methods, I don't know if I love the way that the code is architected for this. Like each of the
Sure.
methods is like generating a list of candidates, and then what we don't do is we don't say like, okay, well, some nodes are drifted and are good consolidation targets, so let's maybe do both in one. Like
Right, right.
we could make, yeah, I was gonna see what James you have to think as well, because I think this is getting a little architecting a solution for a problem that is just caused because we didn't like fix the underlying architecture. That is to say, like, I think there's room to relook at the consolidation pipeline and saying, like, okay, what are the actual steps in the pipeline and how do we want to evaluate across different methods and plug them in? Like, for what we have right now
Mhm.
works, but you're running into like one of the obvious problems, which is
Yep.
like, and
Uh,
then there's other invariants in that that we might want to protect. Like, okay, for single node consolidation, maybe we like right now we just order a list of candidates and we say
yep.
like if we time out processing the first half, we'll never get to the second half. And maybe we
Yep.
want like candidate fairness. You know what I'm saying?
Right,
Like
right.
maybe, or even for multi-node where it's like for every two pairs of nodes, eventually we should maybe have looked at that pair of nodes in the long term. Like you could
I
imagine
agree.
fairness at all sorts of levels here. But I'm curious what James thinks.
Hey, thanks. Hey, Garvin. I really
Hey,
like this. I think it's a really, really good problem. And I wonder, and I also really like the solution inspired by CFS. I think that's really creative. But I wonder if we just change more stuff about consolidation, we can make the solution here simpler. So, if it's okay, I'd love to follow up with you and Jason about this. I don't think Jason's here, but let
No, I don't think
me
so.
set up some time with you guys, and we can just talk through. Like, I think if we get really crisp on, like, okay, this happens now, and I prefer this other thing to happen, then we can talk about the right way to get there.
Yep.
Because I think you're right that like it's not the problem is totally real, but I just wonder like maybe we could do something a little bigger, but ultimately more simple that makes us happier in the long term that fixes a couple of other things. I'm still
Yeah.
reading the RFC and thinking through the implications, so I'm not sure what that looks like yet, but I'd love to talk more about
Yeah, for sure. I think agreed. Like in my mind, as I was writing this, I was like, okay, I think in general, disruption needs to be rethought out because there's pain in just single consolidation can take up like we have to bump our single node consolidation to like 5 minutes because our cluster is complex enough or enough things happen that like the 3 minute we hit it enough. So I agree that generally there's likely smarter things we can do. My worry I guess we can chat about more, but my worry is that the re-architecture, it's going to be big enough that we'll feel this pain for longer, like for like still like a
Yeah,
long time. That's my worry. But yeah,
totally.
happy to chat about it
Yeah,
offline
let's figure
more.
that out
Yeah.
in the next couple of days,
Yeah.
and
Yeah.
I'll send you some thoughts over Kubernetes Slack, and I'll figure
Yeah.
out some time with you. And if we can bring Jason, that's really cool. But
Yep.
I think figuring out what the simplest possible solution that kind of gets you out of the woods on this one, and then what we want to do longer term, I think would
Yeah.
both be really good things to follow up on. But I do really like it. I don't know, maybe it's the
Yeah.
right thing to do now. It
I,
just kind of
I, I
seems like a lot of changes, and I
yes,
wonder if we can do
yes.
something smaller.
I do have some thoughts on how other way, but yeah, let's chat offline and see. Yeah.
Awesome, yeah.
Thanks. That's all I have for this one too. So thanks.
And then Derek, new feature lifecycle
Uh,
guideline.
before we move on, James, could you put a comment on the RFC or something indicating the plan so others can
Yeah,
chime in if they want?
I'll put a note on that.
Thank you. Okay, so this is coming out of Jason and I have been talking about this for a bit. The Carpenter project has for a while just kind of been the Wild West of features. People throw RFCs at us, and then sometimes we don't have time enough to take a look at them, or don't have clear guidelines on we don't have clear guidelines for people to know that their idea is bad from the get-go. So this is kind of trying to take a big swing at the problem in a lot of different ways. Similar to other open source projects in the Kubernetes community, we basically have only so much bandwidth for accepting changes into the project, and we're looking to formalize a concept around it. In this, if you, Josh, if you want to open up the files, in this I've kind of suggested using the priority labels. We might switch those to other labels, but essentially the idea is that like we want to be able to tell the community, one, what are the features that like definitely have to be done by a maintainer because we don't have the time, or like it's not a good scoped feature for an external contributor. And then two, what external contributions we're actually willing to accept. Like, would we accept an RFC about this issue now, or is it like a later type of a thing? And then as well, I've added some scope guidelines that are basically just like, here's stuff that doesn't belong in the project from the get-go. Um, I would love feedback on this from the community. So if folks here are ones that are external contributors, please take a look at this and see how well it works with your workflow, if you'd find this helpful. I'm not trying to say that we don't want to do things. I'm saying that we don't want to do them right now because we're busy. So take a look, let me know what you think. And are there any questions right now?
Yeah, I like to see this because I think a lot of times we're like, what do we do next? How do you get it to not alpha anymore?
Yep, absolutely. Cool. People can take that review offline unless they have more comments, and we can move on to the community questions.
Sounds good. Um, any questions? Whether we'll support eviction request or this cap.
Yes, we will.
Yeah, I think we talked about it a few meetings ago, but I think because this is still early, I don't think we have a full answer to it. I don't know if we have, it's a good call that we don't have any issues on the main core for tracking it.
Yeah. We should also, if there's somebody here who has good knowledge of the project, who's willing to actually follow the upstream cap and get involved there to like make sure that it works for Carpenter, that would be something that like Jason and I have been wanting to do, but haven't had the time. I think the working group that meets for this meets at 9 a.m. on or 8 a.m. Pacific time on Mondays, the Node Lifecycle Working Group. And this is the kind of API that I think the Carpenter community would love to shape for our use cases. So yes, there should be an issue. Whoops, there should have been one already. uh, please follow it and yeah, get involved with the upstream community. I've talked to some of the people writing the eviction request APIs and stuff like that, so they're familiar with Carpenter as a use case.
I've I have one of the guys that's working on that. I sent him some issues, like use cases. So I'll keep trying to stay engaged with them.
Mhm. Disrupted pods prefer scheduling on up-to-date non-drifted nodes. If up-to-date,
It was the person who submitted this here today. No, maybe they're gonna watch the recording after. Maybe it's a time zone thing. I can talk about this. Yeah, this is definitely something that belongs in Kubernetes. If you are unfamiliar with the scheduler-driven autoscaling project that's going on right now, there is a project that's joined SIG Scheduling, SIG Autoscaling, where we are looking at making the scheduler autoscaler aware, basically. Part of it is moving the provisioning cycle into the scheduler. Part of it is doing these extra types of things where when we have node lifecycle information about nodes, that should take into account that should be taken into account in like filtering and scoring. So drained nodes obviously should be filtered. Drifted nodes maybe should be scored slightly differently. So the kube scheduler might prefer to put it on non-drifted nodes. So yes, but the framework to do this is like currently in the works. If you want to join, there's a meeting 8 a.m. on Tuesday mornings under the SIG Autoscaling branch called Scheduler Driven Autoscaling that we are talking about how this integration will look, like what it'll look like. I can link the forum in this. But yes, it's not a Karpenter feature. It's a scheduler feature, and right now it can't do it, even though it could, but we want to do it holistically.
that's covered by schedule-driven autoscaling. Next feature request would be extend termination grace period ad hoc on node claims. Karpenter has a node pool with termination grace period set. So the node's terminating, there's no way to extend the grace period.
This looks like the same person who put the other one, so I'm gonna assume they're not here. But if you are, please speak up. I'd love to chat. Yeah, right now, so this one is a thing that we have explicitly talked about not letting people do because if you set expiration, that might be expiration is a forceful thing, and people use that to enforce security boundaries for patching. So we do not let people extend termination grace period ad hoc as it would allow there are Karpenter users that have the team that owns the node pool settings is like the platform team, and then the team that owns the pods or has the ability to edit the nodes is like the application teams, and it might let the application team bypass security requirements of the platform team or vice versa. There is an issue that I cut recently for formalizing the node termination contract, that this would belong in there probably, but there might be security implications for some users that we wouldn't want to let people do this from the get-go.
I do wonder, I guess technically, like, once the node starts the term deletion, right? Like, can you stop it just by removing the deletion timestamp?
I don't know. I don't know.
The
I feel
deletion
like
timestamp cannot be unset.
ah,
Okay.
okay.
I'm not surprised. If you could, I would be
I was
surprised.
like, that sounds weird, but can you do that? I guess not.
Yeah.
And I guess it's too late, right? Like, okay, deletion time is that, but then Carpenter starts draining, and then the finalizer hits. You shove in a do not disrupt at like during it doesn't do anything. It's too late, right? Yeah,
It's
okay.
too late. And to a certain extent, like the draining workflow, uh, we so TGP right now is set pretty ad hoc by a bunch of different controllers, but as part of formalizing the node termination contract, when you tell Carpenter to get rid of a node with a TGP, um, like we need to talk about the semantics of if that should be extendable or if not, because that might actually be a hard requirement. Like it could be like a spot interruption or like the node is just gonna go away, and so you have to drain the node and uh, or it's expiring because there's like security patches on it. You know what I'm saying? It needs to go away because it's a vulnerability. And we need to have the discussion, and then so I will link the GitHub where we're going to have the formalize the node termination discussion.
That makes sense.
Cool. Then we can talk about workload-aware no termination sequence hinting to Carpenter. This
Okay, I would be fascinated to know the use case here. Like why? I've heard this before for stateful sets where you want some kind of application signal of like I'm running a stateful set with like database replicas and I need to the drift sequencing to know how I can, in what order I can do the nodes because the pods on them have like some kind of internal application state that like needs to be coordinated between the various members of the pods. And we want Carpenter to be aware of that and to like drain intelligently. Um, I'm curious if this is in termination specifically or if it's in drift, because if it's a drift, like ordering right now we do not order, I don't think we order drift significantly, and I don't know if we want to get in the weeds of drift being ordered. Drift should be you should architect your PDBs and we should architect eviction in a way such that drift is a non-disruptive disruption. um so yeah, I'm very
Yeah,
curious.
we should tell them or her. I don't actually know this user's name, but then to like open it, get a issue for this one because agreed. I think it makes some sense, but it would be good to know exactly what they want.
Yeah, I'd be very curious to know the use case.
This is me.
Yes.
Yep. So it's a small PR, specifically around could not schedule error around pods. Um, I guess this is a there's a different issue for this, but at a high level, I've two main issues. One is it kind of spams could not schedule. Some of our nodes, sorry, some of the pods that run on nodes that within the cluster that Carpenter runs in will never be managed by Carpenter. And Carpenter spams every time those pods comes on. It's like, hey, could not schedule. I was like, yeah, I know. Um, and we want to kind of add ability to dedupe pod error for 5 minutes so that it stops spamming. I think at that issue, that 1904, it's also other users who, for other reasons that don't want they could not schedule for certain pods to stop spamming also um, because they have their own reason. I forgot exactly what, but at a high level, it's just that for the same pod, if you cannot schedule and it's going to repeat, we don't need it every. I don't know how often. Like I think it depends on when Carpenter comes back to it and sees it again, or when it requeues to not spam every time. Just say it every 5 minutes or so, so that it stops repeating that log statement, especially because could not schedule comes with a lot of logs. Like it can all the tolerations it doesn't tolerate, all the requirement that doesn't meet and stuff like that. It does a lot of logs going to our logging systems. So that's one of it. The second is right now we don't have the node pool names for all the errors that the pod doesn't tolerate, doesn't have the requirement for. I just want to add that. So it's easier to diagnose, hey, this pod didn't land on all the node pools, but I want to understand exactly what node pool didn't meet what requirements or what tolerations. So that second piece is that simply adds the node pool name as part of the error to say this node pool and these taints did not fit the toleration or whatnot. And then one last piece in there is that I wanted to sort the errors because there is some priority of what didn't fit. So like I think in the code, I can't remember. I was looking at the Karpenter code, but at a high level, like it didn't re meet the requirements. It didn't. I guess going down the line, like first, it like okay, it didn't tolerate the taint, so that's the first thing, the lowest tier because it's like it didn't meet. But then as you get deeper, it's like you met the taints because you have the right toleration, but now your requirements don't meet. That's like higher than the taints toleration, and then I think even lower is like there's some issues with like this AZ or stuff like that. So like I try to sort essentially all the errors for Chinook schedule so that the most relevant ones that it meet like it went deep into the code the if else conditions and then it eventually failed. That one gets service higher. So in the case that you didn't expect the pod to not land a node, even though you wanted it to, in theory, it would be the top error cause. Um, so that's the second like quality of life is like okay. In addition to showing notebook, it kind of sorts all the error causes so that rather than alphabetical node pools, it's whatever it thought it made it through the most rounds, but then still didn't make it. Get service up at the top, and so on.
Interesting. Yeah, I haven't taken a look at this PR yet. I'm not opposed to the logging being smarter,
Mm.
having taken a brief skim of the PR. Um, this is a fair amount of complexity to just reduce logging.
Yeah,
Maybe there's
unfortunately,
a
the dedupe is complicated because of how it's structured and how you kind of have to cache it. So like you end up having a cache pass through so that it knows each round of running that it should not log again. I think what I link in the Zoom chat is the ordering from the unit test is like from bottom hot up is like the lower priorities at the bottom and higher up. So it's like no error, unknown error, taint, and then no port and then requirements and such that. So it just orders the errors from the scheduler log. So it's a little clearer to understand like which one may actually be the one that you cared about and failed. But yeah, the dedupe agreed. Unfortunately, it's a little complicated, but I don't know if there's a cleaner way to do this.
I mean, the use case is primarily for pods that you don't think Carpenter will ever be able to schedule for. Like you've specifically said that this is not for Carpenter, right?
For our use case, yes, but in general, also we do sometimes see pods not land like not ready because I don't. I have to like look again. Like there are periods of time where Carpenter's like, okay, this pod doesn't fit, and then it fits, or maybe it's simply we screwed up the pod selector or tains, and we screwed up the node pool, but it could continue to spam until we either kill the pod, or kill the deployment, or we fix the node pool. And I guess there isn't new information about the fail to schedule after the first few times because it's going to just be the same thing over and over again. And I guess the problem is more on the other side where it's okay to spam a lot if it's not a lot of logs, but there's a lot of logs because it scales with
Yeah.
number of node pools and stuff like that. And we want some way to dedupe that so that it stops spamming with like huge chunk of log every time. I don't know the answer of how to do it, but that's the end goal. Is like, yeah, sometimes we've screwed up, but it just spams like crazy, and we're like, oh no, please stop.
Yeah. Yeah, I guess I might have to take a deeper look. Is there someone else who wants to volunteer to think through this one with Garvin on the call here? I think there's probably a more elegant solution.
Hey, Garvin, let's chat about this one too. I'll find some
Yeah,
time. Maybe we
sounds
can
good.
make it part of a long conversation. It should be
Yeah,
fun.
yeah, yeah. Sounds good.
Thanks,
I guess.
James.
Thanks. Thanks. Sorry, I was screwing up with the hit button. Thanks. And I guess Samuel, were you the one who put in all the community questions? Seems like you're here now.
Yes,
Okay,
I
perfect.
I have put a few things in here.
Yes, that's fine. We were chatting without you, thinking you would join to look at the recording, but we can re-go through what we talked about.
Before we do that, I noticed someone slipped in status check on in-place Omni upgrades.
Oh,
Do we want
it's
to cover
still from
that?
Sam. I
Well,
just
I put
moved
that
it
one in.
out. Yeah, I just carved it out of the paragraph because I realized it's a separate thing than the other stuff.
Oh,
Right.
yes. We're looking at this. We do want to support it. I don't know if there's like I don't think anyone submitted an RFC yet or anything for it. The outstanding questions that we have for in-place Omni upgrades, and maybe you can help answer these use case questions,
Yes.
are around is it actually a disruptive action? Do you need to drain and reboot, or is it a non-disruptive action, depending on the Omni?
So the AMI upgrade process always reboots. So my understanding is it has to be disruptive.
Okay. So it's a can of worms then, a good can of worms, a can of worms that we like and want, which is Upstream Carpenter doesn't have a concept of reboot right now as like a as an action it can take. It wants it now for two reasons in place Omni upgrades, like maybe you want to do drift via reboot, and then two,
Yes.
node repair. So if you have like a device and node repair. So we're seeing a lot of use cases around I'm running some NVIDIA GPUs and they have this like device that sometimes can get broken, but you just need to reboot the device. And so maybe we want to drain, reboot, and then keep it in the cluster basically without having to actually like get rid of it and get it back from the cloud provider. Um,
So we also do run GPUs, but I guess we haven't run into the idea of a reboot fixing the devices. So I guess I'm interested in that as well. But we're definitely the former, was our motivation.
Yeah. So upstream Carpenter, if in place Omni upgrade is a disruptive action, i.e., you probably want to do some kind of node drain on it. We're going to want to formalize the concept of reboot upstream, and that's going to be like an upstream RFC. It's not going to be just an AWS provider issue. Um,
Oh, okay. Interesting.
yeah. Well, because otherwise it's like who does the drain? If the provider's doing it, then that seems like it. I don't think that that's specific to AWS. Any cloud
So
provider would want the concept of reboot.
So I had talked to the node lifecycle working group about if there's any other sort of like temporary node outage status for pods, and from what they said, you can either do a graceful node shutdown or you can just do eviction of all the pods. But either way, it's not really like a temporary pod that's still bound. It's getting removed from the node. So we're dependent upon the persistent volumes in order to rebind the pod to that node. And so I'm going to be looking at how the persistent volumes actually persist across reboot, how that functions. I'm actually not sure exactly how that behaves. I think that's my main open question. But so far, it seems to me like from the Carpenter side, it's still effectively just evicting everything off the node, all the pods. So I'm not sure what the reboot versus terminate distinction is on the Carpenter side, other than the API that you're calling.
Yeah, the only question is like if we wanted to handle things that aren't like don't evict everything, don't drain, and then maybe with reboot, do you like you probably always want it to be forceful eviction eventually? Like you do you want the similar node TGP concept for reboot where it's like this is the grace period for pods to get off my node before I need to reboot it?
Yeah, so
If
we're
it's like an
using termination grace period for this use case, and yes, I think we need everything for sure to move off because you're doing the reboot, so the pod is for sure going to get interrupted, and RAM
yeah,
gets wiped, the root, all the ephemeral storage is wiped, so it's basically like starting over, rescheduling.
yeah. And then the rebind I think is when the node is back ready and we like untaint it and everything, then you're in the scheduler land of trying to get them back onto onto the node, which
Yes, from my conversation with Node Lifecycle, it sounds like that's required. Yes,
yeah.
James.
Yeah, I just had one thing. Did you say that the ephemeral storage is wiped on a reboot?
Um, so it actually kind of depends on whether you have that using the instance storage or not, but generally, so the RAM for sure is getting wiped. The root volume is getting replaced via the AMI, and typically the ephemeral storage is on the root volume, although
Okay,
it could not be.
sure. But like other storage, like if you have an extra EBS volume attached or like an NVMe drive attached, those aren't wiped, right?
So the value in the reboot AMI over destroy and replace is that the instance storage persists. So all the data that's on the instance
Yeah.
storage. And so we could have ephemeral storage be on that instance storage, but more important, at least for us, is persistent volumes based on that instance storage would persist.
And
Well, we
as
need
the
to verify that. But
are you modeling the NVMe drives as persistent storage? It's kind of funny because they're like on the instance. So on in AWS we used to call them ephemeral drives. We moved away from that. But those are persistent to you, right?
so they are, I mean, they're kind of persistent. So we're using the equivalent of the local static provisioner. I think we're actually using local path provisioner from Rancher. But yes, we are creating persistent volumes from instance storage.
Okay, cool. Sounds good.
And this is for cost performance reasons, because if we were to use EBS, it would, well, A, not perform as well, and B, cost more. And this
Yeah,
is largely for
yeah.
stateful systems. Yeah.
Totally get it. Totally makes sense. I was just worried that like, well, if you wipe those drives, doesn't that eliminate the value of the feature? It sounds like no, you don't. So awesome.
So you wipe the root volume, but not the instance storage, yes.
What AMI are you guys using out of curiosity? Custom?
Um, yes, a custom one.
Cool.
Although we have plans to switch to Bottle Rocket, for now it is custom.
I think Bottle Rocket has some fanciness that makes like this even nicer on Bottle Rocket. There's a conversation that some people are having of whether or not Bottle Rocket can do it non-disruptive, like your pods don't even notice. But
That would be
I
very interesting to me. So I know that
yes,
there's the Bottle Rocket update operator. Is that what you're referring to? I linked it on that issue if you open up the issue.
I don't know the weeds of this, unfortunately. I only know some of them.
So if you scroll down, I think my first comment, I linked to it. And oh, sorry, the second one. So Bottle Rocket has a Bottle Rocket update operator, but this isn't actually integrated with Karpenter. So I think this is like a separate update mechanism. But we want something that would effectively supersede this and not just be for Bottle Rocket. Although I'm not sure if this operator does non-disruptive or if it does like a reboot, how exactly it works. But I was told
Yeah.
that this handles the upgrading of, I think there's Bottle Rocket has a separate root volume, and you're able to replace that because it's not actually modifiable by workloads. So you're able to somehow hot swap it over. I do not know.
Yeah, that's what I've heard as well. I don't know the technical details of it, but we would want to leverage that for Bottle Rocket, and then maybe that is just a provider change because you don't actually need to drain.
Right. So my understanding is I would need to add something to the EC2 node class probably to make this something that you could enable or not. And then it should be in the provider calling the EC2 API. Um, so you were saying that there would maybe be some need in the upstream Carpenter for it. I'm still not fully following on that.
That's that's if you need to do the drain. So if you can do the hot swapping and like the workloads won't notice, the provider could, upon seeing a new AMI, know internally, like in just the provider, to not actually drift the nodes via like Carpenter drift, but just hot swap them at some rate. Maybe we need to redefine drift budgets, or maybe it then becomes drift budgets aware, like it hot swaps them according to the drift budget. But if it's non-disruptive, then you don't actually need to do the cordon drain, bring it back. Like you don't need, you could skip all that workflow, and that workflow is um, generic Kubernetes. So that's going to be in upstream versus the bottle rocket hot swapping feels more like a provider only construct. Um,
So you're saying because the workload doesn't get disrupted, but for what we're thinking, we're not using Bottle Rocket yet, and it would disrupt. And so you're saying for that we do need something in Carpenter upstream?
yeah, yeah, because you need to drain the node, right? Because you need to get all the pods off of it before you reboot. So
Yes, but
if the
isn't it? But conceptually, it's just happening from a regular AMI drift. So you're still doing the
yes,
same eviction behavior, right?
yeah, I guess it's the maybe the provider decides when it gets a delete call from upstream, whether or not to actually delete or to replace. Because right now the delete doesn't say this is from drift.
Yeah, I
The
think
delete just says delete.
that's the core issue, right? Like you want to keep the node
Okay.
around, and the natural behavior is to actually delete the node, right? So like upstream need to understand this weird like new paradigm of you can keep the node around, like you drain it, keep the node around, and like reboot or let it happen and then have it back online kind of thing. And I
Okay,
think
so
Upstream does it.
related, I think this is related to if you scroll up to the main post, there's a second use case for this, which is not just the instance storage, but also for rare instance types where we're not able to spin up a replacement, but we are able to take down the node and just reboot it. So this mostly applies to like accelerator instance types. So I think to your point, we would probably need Carpenter to know that it's able to do the reboot in place. But I think that sort of changes the semantics of how Carpenter normally handles drift, where it ensures that the workload is able to land somewhere else. So I think here we would have to effectively have like a max unavailable instead of surging on the AMI drift. Is that something that Carpenter supports today? My understanding is not.
So the author of this issue also has an RFC upstream for we're calling it terminate then replace behavior for static capacity or non-static capacity. Like on drift, you instead of going over one, you just start deleting. There are some hard semantics around that in terms of like how do you honor budgets? Like in a world where you start terminating and then replacing, if the replacements don't come up, then you can run away, terminate. Um, this and that are very similar issues. So I can send that RFC your way if you want to take a look at it for kind of thinking in this world about like, okay, we want some kind of maybe reboot semantic actually fixes their problem more than terminate and replace does. Like maybe they don't actually need the instance to go away and come
Yeah.
back, and they'd be
I
better
think
suited for reboot.
I think ideally we would prefer the reboot, yes.
Yeah,
Just that it would be faster, but
This is something we
let me dig
want
that.
to, so I think the reboot idea is great, and this in place is great. Yeah, I didn't realize this existed.
well, I didn't realize until I think sometime last year we implemented this for upgrading our AMIs in raw EC2. I think it's a relatively new feature.
Yeah, okay, that makes sense.
There's a pull request. What is this?
That's the terminate first and then replace, right?
Oh, I see.
Yeah.
There's a
Yeah.
currently an RFC. It's not accepted yet. Is it still going back and forth? What's the latest on that?
Yes. Yeah. I'm one of the primary reviewers, so I'm not sure I'm happy with it because of this repair conversation as well. So please take a look at a review, leave your comments, your use case of being like, are you actually trying to do this other thing? Because a lot of the people use it for like a lot of people want this kind of replace then terminate behavior for basically like capacity blocks, right? I can't get a new one.
Yes. Yes, that's the second issue. Yes, correct.
Yeah.
I
Okay.
can add something to this because for us, it's less. Well, yes, we also want to keep the instance type around, but the other thing is that we have some pods with very low pod destruction budget, and Drift creates a replacement, and they say essentially very underutilized because the transition from the old to the new is very slow, and ideally we don't spin a replacement right off the bat because that would just be nodes hanging out doing nothing. And I'll add that to the
Oh,
RF.
interesting.
Yeah, I'll add it to the issue. But yeah, like essentially we have okay, we run a weird these guys run one pod per node and we spin up 100 nodes, but the pod distribution budget is like one. So 99 just hangs out until that one pod at a time slowly moves over and that's burning money essentially.
Yeah. There's another kind of correlated issue with this, not to keep raising open questions, but have you guys heard about surge eviction for pods? It
Surge
doesn't
eviction for pods.
it doesn't exist right now, but there's this concept of like, hey, if you're rolling a replica set, like don't you don't need to go from like n to n minus one to replace them. Just go to n plus one whenever. So like I'm trying to evict my pod, make a new one before you actually get rid of the old one, and that way you don't have to be over you don't have to be over provisioned just to be able to drift.
I
Um,
I think is that part of the pod disruption mega issue thing that we have. Yeah,
Yeah.
I think
We
I
want it upstream. So like we want it
yes,
in SIG
yes.
apps. Like we want the eviction API to basically be able to do surge eviction for us. But in a
Yep.
world where you have like you can say this workload should be surge evicted and this workload shouldn't be surge evicted, you could simplify Carpenter's architecture significantly to say, hey, we just do whatever the pods on that node say we need to do. So if the pods on that node are surge eviction, we replace then terminate. If the pods on that node are terminate then replace. For in the node, we terminate then replace because that is the behavior of the underlying compute. And Carpenter doesn't have to do this like pre-spin or replacement or anything. We just like evict the pod and then like react to whatever the actual workload management does. Because you guys don't care about, you're only thinking about nodes because you care about the workloads on the nodes. So if we can shift that burden from Carpenter into the workload, I think it gets a lot simpler
So
from
Derek, what
there.
you're talking about is already supported by deployments, but it's not supported from pod disruption budgets. Is that what you're
No,
saying?
it's more complicated because eviction happens per pod, and the pod would have to know you want to make a new one before it accepts eviction, if that makes sense. And it doesn't go through the deployment because eviction's like it aims it to a pod, and pod has no understanding of replica sets and stuff like that. So
Yeah,
like
so
yeah.
deployments do it when you roll the deployment, right? Like when you roll the deployment, it'll make the new ones and then get rid of the old ones. That's the right behavior. This is on the actual eviction case. So the deployment's fine, nothing's changed about the deployment, but Carpenter is like getting rid of one of the nodes, and so we evict one of the pods. The new pod should come up before the old pod goes away,
Yes.
right? But for stateful sets, you don't want to do that because you don't want you want the actual like stateful set pod to go away first because you don't want to have like split brain and stuff like that. And so like depending on the workload, you might want to configure it differently. And then Carpenter can know to pre-spin replacement nodes or not pre-spin replacement nodes based off of what the workload, how the workload will actually act.
Right.
Yeah, the last thing from Ellis is talking about that search eviction concept from upstream. Or
Yeah.
yeah.
I
Yeah.
don't want to say that you have to solve that problem in order to get reboot and like replace instance storage into Carpenter, but like I want I want to have these conversations because if you see a big problem with that, I might not pursue it. But if you're like, that sounds great, I will keep banging on upstream to like go get that for us.
Yeah, I think we generally have that capacity block issue that you were saying. And for stateful workloads, we're thinking that this reboot behavior probably would be combined with that replace behavior, ideally. And if you spin up an extra node, it's just not going to be useful for the existing pods that are trying to rebind to that persistent volume. So it's kind of a waste. Right. I guess I'm not even sure if Carpenter would schedule another pod because it has that persistent volume claim. So maybe it's not satisfiable by another node. I'm not sure exactly how
Yeah.
that behaves.
Yeah, I actually don't know. You should, if you test it, I would assume Carpenter would see the persistent volume claim and be like, oh, I can't make a node for that because
Yeah.
I like it's still attached to this existing node.
So then it's probably fine for the stateful workload use case one, but the capacity block where we don't have a persistent volume, it would be concerning, but separately.
Yeah. Yeah.
Okay. So I did have other feature requests. I don't know if you had anything more on this one.
No, let's move on.
Okay, so the disruptive pods prefer scheduling on up-to-date non-drifted nodes. I saw you linked to scheduler-driven auto-scaling. It says that it's
Yeah.
like pretty early stages. I
Yeah,
was,
so you need this in the scheduler. If you're going to do it, you can write a scheduler kept for it today. You could make you can make a plugin that like that scores nodes based on whether or not they're disrupted. If you wanted to do this right now, you can do it
well,
with
not
plugins.
on whether they're disrupted, but whether or not they're drifted or not. But yes.
Sorry. Yeah, you could do it based on their drifted. You could like look at the pod, or the Kube Scheduler's plugin framework lets you filter on whatever. So you'd get like, oh, filter this node for this pod, or score this. Sorry. You can score things. You would say score this node for this pod, and you'd say in the node it's drifted, score it worse. In the node it's not drifted, score it better. And you could do this today. Um,
But it's actually
scheduler
in the
driven.
node claim, not the node itself. Is it still able to do that?
Oh, no, it's not because it's not node claim
Yeah,
aware.
that's the
So we'd
hard
have to
part.
Yeah, okay. So schedule-driven autoscaling is the project we're taking on with SIG scheduling, where we're moving a lot of Carpenter's core scheduling into the scheduler. And so the scheduler will become like autoscaler aware by default. And these features get a lot easier to do because node claim will probably just become an upstream concept. And so the
Oh.
kube scheduler will be able to do this kind of stuff. It's very early days because it's like we're basically rewriting the entire kube scheduler. But that's where these types of features are going.
So my naive idea was, in addition to the condition on the node claim, you could also just update a label on the node, and then you could do an affinity in that sense. Is that reasonable?
Yeah, but we probably wouldn't accept it into the project because I don't know if you actually want a drifted as a scheduling label, but for other things besides this, and this should be handled more by a score than like a can't. You know what I'm saying?
And an affinity, yeah. It'd be a
Yeah.
preferred affinity, yeah.
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 I mean, if you're going to change the label, you can do this separately, right? Like you can do this, you can label it, and then you can have a new plugin for scheduler to do it. It's also not great. But it does, I guess, like at a high level, it feels like you want Carpenter to inform the schedule or something. And I think what Derek's doing with the upstream is slightly the cleaner than any other
Yes,
hack.
it does seem cleaner. It also seems like it would take a longer time.
Yes,
Yeah.
unfortunately, yeah.
So if you want to do something hackier in the meantime, you can like it's simple enough to write a controller that reconciles node claims and nodes and adds the label, and you can do the preferred like affinity
So
if you
so you
want.
wouldn't accept that short-term upstream you're saying, so we should just do that
Probably
ourselves.
not.
Okay.
Probably not.
I guess that resolves that then. I will not file an issue. The extended termination grace period ad hoc on node claims. I think that's the next most important one I wanted to cover. I see we're at time. You linked to an issue, so maybe I can just follow up there, read that, and comment on that one.
The important context is in the first one, which is like there are users who use termination grace period as a patching security boundary, and so we don't allow people to ad hoc increase it, but we talked about letting people ad hoc decrease it. If the increasing it is the actual definite thing you need, then we need to have the argument over whether or not that actually should be a security boundary, like because people use it for expiration, basically.
Right, I understand. So our use case is we're running stateful workloads. The last pod with the last replica of some data is on this node. We need to prevent it from causing data loss.
Yeah, what's actually terminating the node in that case? Is it expiration? Is it drift?
Termination grace period on the node.
Yeah, no, what's called the actual delete?
Oh, well, this would typically be in like an AMI upgrade scenario, so a drift. Yeah.
Oh, so you don't have the yeah, because this is the whole issue of like stateful sets don't do the readiness probe properly, right?
Yeah, wouldn't PD
Um,
be protected? I guess what is allowing the last one to be killed before other ones are ready?
the termination grace period forces it.
Yeah.
But I
So like
thought it
I
wouldn't
think
start.
this is actually related to the third one, the node termination sequencing, because for example, we could say, hey, this node has the last replica of some data on it, so go evict some other nodes first. But Carpenter doesn't have that knowledge, so it goes ahead and tries to evict whatever drifted node. And then we can block it via the eviction API up until the termination grace period, and then it's gone. We can't stop it.
Yeah. Is your TGP really low, or because we don't really recommend people setting TGP super low?
By default, we have 1.5 days.
Okay. And so it's just like within 1.5 days, you can't get the like other replicas up and in leader.
So normally we would, yes, but this would be an exceptional incident case, and we would like to be able to manually adjust it in that case.
Yeah. Yeah, I think that makes sense. Um, The issue I linked is for formalizing the node termination contract. So right now TGP is the contract where like when you call delete, you set that annotation, but the annotation is like very well not like it's opaque to users. It's not super formal in how a carpenter treats it. There aren't this rules of like can you extend it, can you not extend it. So the issue I linked is like are the carpenter wanting to make that like a formal contract that is like here is how a node deletion message gets sent to Carpenter and what you need to send it and how we treat it. It's not going to help you with the extending it ad hoc because I think all the current conversation is about only allowing it to be decreased. But the one who knows more about that is Jason. So if you follow that issue, you and him can have a discussion about that, I think, in the future.
I guess one thing
Okay.
is like wouldn't, I guess, is your pod disruption budget too lax, or it just doesn't understand that the data is on the last one and a new one didn't come? Like in theory, pod disruption budget blocks this from starting, right? Like TGP, like determination from starting, and TGP doesn't start counting, or does it actually do?
So we're not able to use the pod disruption budget because that actually has limits. You can only have one pod disruption budget per pod, and we
Yes.
typically have multiple different partitions on a single pod. So we are using the eviction API instead to block it, doing a webhook on that, or a validating emission webhook to block the eviction API.
Oh, then it's too late. Okay. I guess we have similar issues, I guess, in our airflow setup, and we just hack the PDB to listen on a signal that we control so that it blocks it like earlier and like okay if there things are transitioning the data's not there we just make it unhealthy make the health check unhealthy so the PDB is always violated and no one gets termination started
So you're like
rather than
hacking the
block it.
readiness probes just to trick the pod disruption budget?
Exactly.
I don't know
Because
about
it needs
that.
it's hacky AF but that's the only way to give it smarter readiness that has concepts beyond.
Yeah, so that's like the node termination sequence hinting. You're telling Karpenter before it gets to the point of trying to evict the node, like, hey, you
uh,
can't evict this one because it
yeah
checked the
because
pod disruption budget before evicting, right?
Yeah, because some partitions is not the data's not there yet. It's terrible, but it kind of works. And there isn't a cleaner solution, unfortunately, until I don't know, until some other thing happens. But yeah, essentially, that's a hack we have because there's no way to. Yeah,
So I think most of the time we do want the regular behavior where termination grace period does force it. We're just saying that if we're in an incident, we get manually paged. We would
yeah,
like to have the ability to prevent this from happening.
that makes sense. Okay, then yeah, it's like too late for PDB, and yeah, yeah,
Yeah,
There
because
is
we
definitely
would
room for some
expect,
work here.
yeah, we would expect that replicas would get replicated elsewhere and things should work out, but exceptional case. Yeah.
There's definitely some work here to like stateful set it does not have stateful set eviction request and like disruption do not have the right interfaces between them to be able to communicate the complexity of stateful sets disruption to all the parties involved. And so there's definitely work here either in the eviction API or in PDBs or in some other thing, probably something in Karpenter as well to iron out this case because we do see this frequently. Like this, the reason why I was like, hey, would like to know the use case is this Kafka. It's because everyone comes to us and is like, yes, I'm running a database and partitions are annoying and Kubernetes does not handle it well. So I wish I had a better answer.
All right. I think that's all for now.
Cool. Thanks for coming.
Did you want me to file a new issue for this extended termination grace period, sounds like?
I think add your use case to the formalizing the node termination contract
Okay.
API. I think the sequencing, I think, is if you cut an issue for it, I would probably direct it to the eviction request API because you don't actually care about node termination sequencing. You care about making your workload level drainability signal available to consumers within the Kubernetes ecosystem, and then Karpenter should consume that signal. So you need a finer grained PDB or eviction request or something like a dry run.
Yes, correct.
Yeah. And then we can use that signal when deciding what to disrupt. But we're not going to do it like ad hoc in Karpenter. We want to do it the right way.
Yeah, we could maybe discuss that more next time.
Yeah, absolutely. Thanks for coming.
Yep. I'll see you online probably.
Thanks, everybody.
Yep, thank you. We are out of time, so I will stop the recording here. And um, there's absolutely nothing else that needs to get brought up now. We're all good. Thank you everyone for coming, and stop recording.